All right, guys, so in problem 2 here, we're going to start looking at the horizontal shift. So if you actually go back and look at your notes on the front page, you can see here we set up the horizontal shift under the radical. That's why we say that that's x minus h, because that has to apply to our x value before the radical is taken. So if I actually look at these problems right here, I want to model x plus 4. So since my equation is x minus h, I would actually have to make my h negative 4 to do x plus 4. And notice what we see. Sorry, I got to get rid of this k value. My apologies. We need to set that k to 0. So notice that my parent function had been right here starting at the origin. And when I make my h negative 4, which actually shows it being h plus 4, what we have right here, it's actually going to shift it to the left. So again, you should remember that my horizontal shifts are always counterintuitive. If it's under the radical, it's going to be a horizontal shift, and if it adds 4, it's actually going to shift to the left. So I bet you can guess if we subtract 1, we're actually going to shift to the right. So there's our parent function. We shift our left to do plus 4, and we shift it right to do the minus 1. So now if you try this on your own, think about where would x minus 3 go, or radical x minus 3, and where would radical x plus 2 go. Take a second to write down your answers to that. X minus 3, of course, is then going to shift to the right, and x plus 2 is going to shift to the left that many spaces. Now we can combine horizontal and vertical shifts, which we will get to here in just a moment. But again, I'm going to stop the video just for part 2, so move on to the next video for part 3.